Okay, um, we're back with showing how a recurring decimal can be written as a fraction for grade 10 mathematics. If we have a number like 0.1 with a dot here, that dot signifies that this is recurring or it's a repeated pattern. So, first thing that you need to do is to rewrite this as a full recurring decimal. So what do? We let an unknown value x, which we're trying to solve, to become 0.111111 all the way up to the never ending. Why? Because that dot signifies that those 1111s are repeated. Okay, then we continue. As we continue, we need to multiply both sides of the left hand side, which is here, and the right hand side by, so let's say multiply both sides by multiples of 10, 100, and 1000. Okay, what happens when we multiply the left hand side by a 10? Multiply x, multiply by 10, you get 10x. And if you say 0.1111111111 multiplied by 10, you get a 1.11111111. Okay, then you make that your first equation will be this one, and then your second equation will be this one. You can go on and multiply by 100 on both sides of equation 1. So, if you multiply by 100 on the left hand side, you get 100x. Then this is equal to, multiply by 100 on the left hand side, on the right hand side of 0.111, you get something like 11,1111111 all the way up to the last bit. So now you look for an equation. I think I should write this down. You'd have to look for equations where the decimals after the comma are similar or are the same. Are equivalent in such a way that when you subtract both equations, you get just only a whole number on the right hand side and a whole number and a variable on the left hand side. Well, with our example here, it will not be possible to see what I'm trying to say, but in the next one, it will be possible. So let's finish this one up. So we can already see that this decimal here and this decimal here and the first one are all the same. So we can just choose to say the first equation and the second equation, we're going to use them, whereby first equation is this one and the second equation is this one. So if we say we're subtracting equation 2 minus equation 1, so everything on the left hand side will subtract everything on the left hand side, and then right hand side will subtract the right hand side. So this is basically saying 10x minus an x is equal to 1,111111 dot 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 minus 0,111111 dot dot dot. If we say 10x minus x, we get a 9x, and then 1,11111 minus 0.111. That's basically like saying 1 because these are going to subtract each other, the decimals. So we've eliminated them. So this is basically saying like 1 minus 0, of which of course it's a 1. Now you're left with 9x equals to 1, divide by 9 on both sides, and then you have x being equal to 1 over 9. So basically 1 over 9 is your 0.1111. Now, back to another example. Let's say now you have 1.75 with a dot and dot here, which means the repeated here, as we would do like in the previous example, we have to let x be equal to 1.757575 all the way up to, and that is our equation 1. And we need to multiply on both sides of the equation 1 by multiples of tens, hundreds, and thousands until we have the decimals on after the comma being the same. Alright, let's start with 10. Multiplying by 10, we get 10x is equals to 17.57575 all the way up to. But if I look here, this decimal and this decimal, they're not the same. So which means I must continue and multiply by multiples of 100. If I say 100 times x, I get 100x, which is equal to 175.75 75 75 75 all the way out to, and that's my equation 3. Then this tells me that the decimals after the comma, which is 7575, are the same as these ones. So therefore I'll be considering to say equation 3 minus equation 1. Why? Because the decimals are going to disappear when you're subtracting those, and we'll be left with those whole numbers being 175 and 1 in here, these two. Alright, let's do the subtraction. If we do the subtraction, what do we get? We get 100x minus an x, which is equal to 175.7575, continuing or recurring, minus 1.7575. And what's 100x minus x? We get 99x. And what's 175.757575 minus 1.757575? Definitely we are going to get these to subtract. But in those subtract, the whole numbers are going to be left, and they're the ones that are subtracting. But I don't like to do it all at once, so I'll just say this is basically like saying 175 minus 1. So 99x is equal to 174. Now, for us to get that fraction value that is equivalent to 1.7575, we have to divide on both sides by 99. Then we're left with an x is equal to 174 over 99, which is equivalent to a 58 over 33. So if you type that, you get 174 over 99, which is 1.75757575. Real quick. Okay. Thank you.